Okay, so we said they're going to focus on the numbers. Calculationally oriented student will focus on the numbers. They'll think about what formula can I use. They'll think of maybe look for a similar problem exactly the same with different numbers and follow that kind of procedure. Okay, so how do you suppose that a conceptually oriented student will start a problem like this? Not this problem, but like this. So what do you think a good first thing to do would be?
They would draw a picture.
Okay, draw a picture. Yeah.
And define like all the variables, like what each thing would be.
Good. Define variables. Draw a picture.
Make a function of y in terms of x that uses variables.
Okay, so create a function. So maybe create a function. But drawing a picture and defining variables are kind of two parts of kind of a bigger kind of thing. Yeah.
They're going to try to figure out. They want to know exactly what's being asked of them, like what the problem is that they're going to have to try to solve instead of the
Okay.
numbers behind it. They want to know.
Okay, maybe that's more calculational. Like, what exactly is the answer I'm trying to get to? So as opposed to that.
I was going to be like understanding the question that they're giving.
Okay, so all right, so yeah, okay, that's yeah.
I guess I didn't say it the way I
Yeah.
was meaning it.
But instead of focusing on the end, what is the focus?
The process.
Process, maybe, or what even before that? What's that?
Why it's all like when you define it.
Okay. So really, the focus is off of what specific question I'm being asked to what's going on, like understanding the situation presented to them before even thinking about what's being asked of me or where I'm going with this. But just taking all the information that's given and getting a really good image of the situation, understanding the situation. So part of that is drawing a picture. Part of that is defining the variables, identifying quantities, which ones are changing, which ones are constant. Okay, and so I really want to encourage you that when you come to real world problems, have a mindset of I just want to understand what's going on instead of what's a method or procedure to get to an answer. Does that make sense? Okay, so as you were working on this problem or situation, so how many people? Okay, how many people had this image of the problem? Did you have this image of the problem? I see some nods. Yes? No? Okay, so certainly some kind of picture to get us started is going to be helpful, right? We got a car going from Phoenix to LA. We're going surfing, right? Going surfing. Got our surfboard. So here we go. So let's really, if I were to say that, I'm going to define X. I think maybe did the problem do this? Did they say X is the time since leaving Phoenix? And Y was the distance from the car to LA. Okay, now given those definitions of those variables, I want to add to this picture. I want to add to this picture specifically related to distances, Y, or Y variable. Okay, sorry. All right, let me give you a little more guidance on this. So yes, you guys are on the right track. You're on the right track, and so let me give you some guidance here. So we're going to have there's going to be some initial reference point somewhere along the way. So basically this, I'm showing this starting 3 hours into our trip. Starting 3 hours into our trip, okay? Again, you have to freeze this. You're going to have to freeze this at some point. You can't draw it changing on your picture. So lots of you, I think you got Y. So, and then I'm showing two other things there. So take this from here and go from here. Keep going. Go. Okay, so then the idea of y final came up. Is y final the same as y or not? So I heard yes, and I heard y final would be 0, which is originally what you said. So it's kind of like either. So it's like how are you thinking about it? You can think about y final as just a changing quantity. It's y. Or you can say, well, I have a specific y final in mind, and that's here, or whatever, or 0. Okay? So that's kind of up to the way you want to frame it yourself. Okay? But y initial is not subject to debate. And these three are not subject to debate, right? For sure, the black one is y. Maybe you also want to think of y final as changing, right? dy is the change, and y initial. Okay, question?
Why is the blue line not y final minus y initial?
Okay, because what does y final minus y initial equal? What is y final minus y initial? I'm glad you brought that up. That's the change, right? That's the change.
So that's that.
So what do you notice about this? Y final minus y initial is dy. Okay. So yeah. So let's go ahead and say that y final is synonymous with y. Okay. Is that okay with everybody? Yeah. So y final is this changing quantity. It's where it's the current value of y. Notice anything?
That it always equals y initial.
What always equals y initial?
The two together, which is y final supposedly, plus dy is always y initial.
So you're looking at this picture and saying y final plus dy equals y initial.
Yeah.
Is that the same thing as this? Are these the same?
Yeah, it's the same. No, because if you do the algebra on the bottom one,
Yeah.
you have to subtract y initial to the other side, right? And then you have to subtract the dy, which gives you y final minus y initial equals negative dy. And
How about, can I just subtract y final? And then we know that we can commute. So are these the same?
I guess not.
What's going on here? The picture seems to say that y plus dy equals y initial. But then that's not what we know dy should be, y final minus y initial. Right? Talk. What's going on here? People's got the gist of it, right? What's the key thing here? What's going on? dy is negative. dy is negative, right? If a quantity is decreasing, the change is negative, right? So then how does it make sense with the equations? Does it make sense with the equations? Does it make sense with this? How does dy being negative then resolve that this is still, we're still rock solid with this right here? Yeah, Autumn. Yep. Right. And I think you all kind of arrived at that. Exactly right. If y final is less than y initial, that's the idea of change, decrease, right? Decrease, and then the result is, so y final being less than y initial means you're decreasing and your change is negative, and that all makes perfect sense with that. So our problem was down here assuming what? All positive, right? When we wrote this, looking at the picture, we thought we were thinking all positive, right? Wrong. Okay. Okay, good. So, how many people had this kind of understanding of the situation as you were tackling the problem? Yeah, somewhat. Yeah, somewhat. Okay. All right, but I would suspect that this is more holistic or maybe deeper than you ventured. So I'm going to show you now the values of x. X is, again, the time since leaving Phoenix. Y is the distance to LA. And then so then as the car's moving, here these values are changing, right? So what is x doing? Increasing, and we know that y is decreasing because we're getting closer. Right, so is y changing at a constant rate with respect to x? Yes or no? Is y changing at a constant rate with respect to x? So talk about your tables. Why? So some are saying yes. Make your case at your table. Go. Why is y changing at a constant rate with respect to x? Okay, I'm going to show you now the ratio of y to x. So at any moment, this number is telling you what the ratio of y to x is. We know that x is increasing and y is decreasing, and so then that y over x value changes as the car goes. So is y changing at a constant rate with respect to x? How many no's do we have? Confident no's. How many still uncertain? Okay. All right, here we go. Same thing. Now I'm showing you as dy and dx change. This is current. This is always updating. It's always updating the ratio of dy to dx as these change. And there it is. Okay. So as dy and dx are changing, so is dy over dx. It's always calculating it moment by moment. Go. Is y changing at a constant rate with respect to x? GC has the ability to, you can open a second window and have like two graphs at once. And the way you do that is you use apostrophe, which is a little unfortunate because you may associate that with derivative, like prime. But in GC, it doesn't mean that. It means whenever you use x apostrophe and y apostrophe, it's all related to a second window. So if I do a new command line and I say, let's plot a point. So I'm going to plot, but in order to plot a point, so in the second window, you have to do you can't just do one control-2, you have to actually do this. So I'm going to say x apostrophe and y apostrophe. I'm going to plot the point xy, so capital X. So capital X and capital Y are free variables. I'm using those. Those are not indicating graphing. It's lowercase x and y. So capital X and Y are free. And I chose those just to be our variables for x and y. And so now when I do this, it's going to open up a new graph window to the right. Oh, it's going to get a lot better. It's going to get a lot better. Okay, and so then we want to zoom out. So then you have this, your zoom in and out, you have separate controls for each window. So I'm going to zoom, out on the, so that's pretty decent, okay? And so now, because those x and y were variable, so now that point that's graphed in the second window is graphing number of hours from L, so now we're at the graph now. So x-axis is number of hours from L, or number of hours since starting driving, and the y-axis is our y value of what distance from LA.
That's how I pictured it. More, that's closer to how I pictured it.
Okay.
We reached LA at 8 hours. 7.78.
Okay. So where did we land? Is distance from LA, y, changing at a constant rate with respect to x, number of hours since Phoenix?
Yes.
Yes. Yes? You changed your mind?
Yeah.
How about this? So you guys? Yes? Same question. Is y changing at a constant rate with respect to x? So Leo's still scratching.
We feel like you're trying to trick us.
I'm not trying to trick you. I'm not trying to trick you. I'm trying to unravel this situation completely to either expose or confirm your knowledge of constant rate of change. Okay? Expose that something's not quite there yet.
So can you say,
Let's talk about it now. So remember back this, I think day 2. So remember this example. We said that you could know for any number of hours, you can know how many miles. If you're going at 70 miles per hour. And we said this is cruising at 70 miles per hour was an example of constant rate of change. And we came up with this. That the change in distance is 70 times that change in time. So did this formula, here's the big question. Question of the day. This is going to answer it. Does this formula mean that dy and dx are in constant rate of change, or does it mean that y and x are in constant rate of change? Does it mean that dy is in constant rate with dx, or does it mean that y is in constant rate of change with x? Which?
It means that because dy and dx are in constant change, y and x are in constant change.
Because they're proportional. I think that's what you meant to say. Because dy and dx are proportional, it means what?
It means that x and y are also in a constant rate of change.
Yeah, I guess so. Yeah. But
Fine, I'm saying funny.
they are, yes. It means that y and x have constant rate of change. It means that y and x. How do we test the rate of change of two quantities? Do we test y equals kx? Is that a test for constant rate of change of y and x? What's the test for y and x being in constant rate of change? dy equals k dx. When the changes are proportional, then the original quantities have constant rate of change.
So that's like the slope,
When the
right?
changes go, what's that?
As long as the slope is constant, then
If the slope is constant, yeah, if the slope is constant, let's go back.
When the changes
When the changes are
are proportional,
proportional, that's dy equals mdx, or dy over dx is a constant. That,
x and y are constant.
yes, y changes at a constant rate with respect to x. So we're seeing an example of, okay, that doesn't mean that y and x have to be in a constant ratio, because if that constant rate is negative, they won't. That's what we're seeing, right? That's what we're seeing. All right, so let's just pick a point here. So what will it mean for the graph of all correspondence points of x and y over here? So all correspondence points of time since started driving and distance to LA. If we looked at all possible, here's one possible correspondence point. What if we looked at all the correspondence points? What are we going to get? Yeah, if I looked at all points like this one particular point, we're at 4 hours, we've been driving for 4 hours, and we are 217 miles. We've been driving for 4.1 hours. We're 217 miles from LA. That's one correspondence point of x and y. If I were to show all the correspondence points like that, what would you see?
A line.
Is it a line?
A line with negative 57 and what?
Right, right. The rate of change is negative 57, which is a constant. Okay, so we want to do that. So we want to use constant rate of change to write all the correspondence points. So we're going to start with this particular one here. What is, 4.1, 217. Okay? And now we're going to just let this another point here stay right there. But we're not gonna look at the actual coordinates of that one, because this one is going to represent any possible correspondence point on this line. So I'll move this back. We don't know what it is anymore. There we go. Okay. So that second point represents any correspondence point of x and y, so we're going to call it what? How can I label its ordered pair? x and y, because they're variable, right? So that's that. I could have drawn that anywhere kind of in the along the line or where those points are going. It represents every point. So it could represent this one, these back here, further down, okay? So by now writing figuring out what y equals, we will represent then every single correspondence point. Okay? And that begins with our initial point. So this is our initial point, 4.1, 217. And so what comes first? What comes first is a change in x. The change in x from our initial point to, it's the straightest line I've drawn all day. All right, it's the change in x from our initial point to x. So we're going to call that's dx. And how can I write dx? What is dx equals what? X minus 4.1. Do you see that? Final value of x minus initial value of x. When x changed that much, how much did y change? Now we don't want to do final minus initial this time, okay? Instead, we want to use what we know about constant rate of change, right? That one's not as good. All right, so I could say y final minus y initial, but I'm trying to figure out what that y final is, right? This is my goal. My goal is to write what that is. So instead of using y final, I've got another way to find dy. mdx, right? What is m? So yeah, so I'll write that. mdx. M is negative 57. dx is, we just found it, x minus 4.1. So I got my change in x. I'm going to get that final x minus initial x. I'm going to get my change in y using constant rate. Given any change in x, the change in y is negative 57 times the change in x, right? That's our mantra, right? That's our mantra. Given any change in x, the change in y is the constant rate times the change in x. So all we've got left now is to write what is y final, or in other words, y. Y final is, now that we have the change in y, how can we build y final? Yeah.
217 plus negative 57.
So 217 represents what? What does that represent, Britt?
Y initial.
Y initial. I've got y initial, and I'm going to do what? Plus the change in y gives us y final, right? Remember that? Remember that? So we developed that. Remember when the smartphone activity? We came up with that. The y smartphone, the bars. Remember the bars? Did we do that Tuesday? I think so. We came up with that, and so therefore y equals, y initial is 217 plus negative 57. That's it. So what is this? This is an equation that represents all of those correspondence points. Given an x, given a number of hours having driven, it tells you the corresponding y distance from LA, right? So given any number of hours driven, this will crank out the correspondence of how many hours or how far from LA we are in miles.
So is that just y equals mx plus b?
No, is it y equals mx plus b? So that would mean this is b, right? Is that what you're saying? Is this?
I don't know if that would be b because you haven't done the math yet with the negative 4.1 and the negative 57.
Okay, so we could, yes, if we did the math, right? If we rearrange that, then we could get it into mx plus b form.
Okay, yeah.
So this isn't mx plus b. This is what we're going to call point slope form. Point rate of change form. Or point slope form, whatever. Instead of y equals mx plus b. What's the advantage to this? Why is this better? So mx plus b. Advantage. Right. So yeah, so often mx plus b is just the result of some procedure where you were given 2 points, or you were given a point, you're given something, and it was a procedure to end up with that. Okay? But now she's saying everything has meaning. So 217 and 4.1, that's what we're, in this particular version of the line, we're using as our like an initial point. And then the rate is negative 57. So what else has meaning? What does all this mean that I'm circling right now? What does all that mean? dy, right? dy, how much y changes from our initial y value, right? And what is just the x minus 4.1? The dx from our initial x value, right? Other comments? Advantages to this? What if our real journey wasn't perfectly constant rate the whole time, but maybe it did something like this? Why is this point rate of change form better than y equals mx plus b? So why is y equals mx plus b less? Not optimal. Okay, so what about y equals mx plus b now makes it less optimal? Yeah.
Well, aren't they both straight lines anyways? So I don't see how it could be less optimal if they're both.
No, but if the situation was this, but when we get here, we start that constant speed of negative 57. So this is a line here, but the real journey did something else before. That makes sense. So then, where does this fall short? Where does this fail? Right, and so therefore, what is b, guys? What is b? The y-intercept, which would be meaningless, right? It would be meaningless, right? So that y-intercept in y equals mx plus b would have no bearing. So when you're piecing together functions, and you're piecing together linear functions, each of those pieces, the y-intercept of each of those pieces is meaningless, right? To the actual function that you have. But if you're how does this help when you're piecing together functions, right? You start with a point that you know, and you continue that piece at this rate until you go on to the next maybe piece, right? So everything there, if this is just one piece of a piecewise function pieced together, then everything there is meaningful.
Right, but in that same instance, using the better one to still get your b-intercept, your y-intercept, would still get you that high point regardless.
Right. And what I'm saying is expressing it that way. If you express it this way, then the number b would really have any meaning.
Then it's glaring obvious that it's not correct, whereas in the y equals, then it looks...
So everything here would have meaning. If the true journey was this solid red thing like this, then everything here still has meaning. Our initial point and our rate of change.
So it's slightly better.
But also just the process of building, using constant rate of change to build it, it took us a lot of understanding to do that, right? So this process, 1, find the change in x. 2, find the change in y using constant rate of change. And then find y final is y initial plus the change in y. So these are deep principles, right? These are important principles about quantities changing together, right? So that just for that alone makes this more profound, right? This is more profound, okay? Because it's all based on these important principles of how x and y are changing together. All right, so let's put that equation in. I've made this a mess of this, so I'll get rid of it. So then if I come over here, hopefully someone wrote that down. I'm going to do y apostrophe equals 417, 217 plus negative 57. And we only want that from 0. So we'll just say constant rate the whole way. All right, 0. X apostrophe to, I think it's something like 8. Gives the whole graph. All right, and then that's going to do nothing. Thank you. Yep. You are right. So there are all the correspondence points of x and y, which is a line. Does y change at a constant rate with respect to x?
Yeah.
Yes, right? Because that. What is the test? Is it the ratio of y to x? No, the test for y and x being constant rate is the ratio of the changes being constant. Going backwards. Okay. Did you learn something? Cool. All right. So, really important stuff. And so this, anyone, so hopefully you've started reading the article yet. Started reading the article, we still got something to do. I'm not wrapping up. But if you've read the article, you're reading about what we mean by didactic object, okay? And so this our whole conversation was built around this animation, right? And building this animation, little by little. And as we built that animation together, there was a journey of a conversation that I wanted to have, okay? And that's what didactic object is about. And you're going to read about that for Tuesday. If you haven't started yet, it's even the part that I assigned is a little bit long, okay? Just be glad that I took the whole first part out, because then it would be awful, okay? But that's why I gave you extra time. So we've had a couple weeks, so definitely don't wait till Sunday or Monday to start that article, okay? So let's go to the laptop battery, and let's build the equation of the line the same way. I want you guys to practice that, building the equation of the line the same way we did here. Okay, so let's all use the initial point here, which is what? 3541, is that right? Yep, so you're gonna do the same thing. And so then this is gonna be this point here, any x, y. So let's see, TP. So we'll use T, number of minutes since class week. Are you guys ready?
We're still pulling it up.
Okay. So actually, you don't need GC for this exercise. You can write it on paper, that's fine. You can just sketch this. Because well, at the very end, we'll put the equation of the line into GC to show that it's correct. But along the way, you don't need GC for it. So we've got this initial point, 3541. This represents any time later or earlier, okay? And the corresponding battery percent. So we want to find what? Same thing. Our goal is, this is kind of like P final. So P equals what? And then you got 3 steps. So this is a procedure, but this is a good one because it's based on, like I said, these deep principles of constant rate of change and changing quantities. So 1, 2, and 3. Everyone practice. Okay. Tell me. No, never. Never want the final answer. I always want your thinking along the way. What's that? Not dx. dt, okay. Right? Uh-huh. Right? All right. Brittany, or Britt, did you have your hand up? Is that what you did so far? Okay. So yeah, we'll have someone else take over. Good job. That was great. Okay. initial, right?
Initial 41
Okay. Okay. Does P change at a constant rate with respect to T? How do we know? How do we know that P changes at a constant rate with respect to T? And yeah, what's the constant of proportionality? That's right. Yep, because this is constant, and this is dP over dt. That thing's constant. So now, again, if we put this in, we can do it. So now, we need y and x for GC, right? So y is 41 plus negative 0.325 times x minus 35. And how long was class? Class went from 0 to, if I told you that, yeah, 90 minutes. Yes, if you've defined m previously correctly, I don't know if I have, let's see. Yeah. Yes, she's saying, can you just put m in here? Now, it would be, but we would need plus m, right? Still works. Yep, since m is already defined, you could do plus m. Okay. Any questions on this? What about the ratio of P to T? Would that stay constant for different correspondence points? The ratio of P to T? So when does the ratio of P to T stay constant? Yeah. So when you have a positive rate of change and your y-intercept is 0, that's the one type of constant rate of change where your quantities also maintain a constant ratio. So any line like this, is going to give you also the y equals kx is true. But any other line, anytime the y-intercept is not 0, or you have a negative slope, y over x is not constant. This does not hold. But that doesn't mean you don't have constant rate of change, because constant rate of change, the real test is ratio of the changes, right? Ratio of the changes. That's the real test to see if you've got constant rate of change of the original quantities. Okay, so you've got your